Hey everyone, this is Abby. I just wanted to go over the recitation number 14 worksheet because I think there's a little bit of confusion, especially surrounding the organization of this worksheet and the fact that there were two different dextrose solutions, and I think that caused a little bit of confusion. So I just want to clear up that and any lingering questions that you might have. So as you're watching this, if you still have some at the end of the video, please feel free to email me or stop by my office hours, and we can definitely go over some more of it. So the first thing that I want to point out is that the first dextrose solution, called D5W, is 5.0 mass by volume dextrose and water. And what that means for us is that there's 5.0 grams of dextrose in 100 milliliters of water. And we get that from this definition here of the mass by volume percent. So that's really the most important information about this D5W solution, and we'll use that a few times throughout this worksheet. So the first question is, calculate the mass of dextrose delivered to a patient if 250 milliliters of D5W were to be administered. So we're going to start with our definition of the D5W solution, which is 5.0 grams of dextrose in 100 milliliters of water. And this you can kind of think of as the concentration of dextrose, but we're sort of scaling it up with 250 milliliters. And we have a unit of volume here on the bottom, and we want to end up with a mass of dextrose. And so we have grams on the top, and we want to keep them on the top. So that means we have to multiply by a volume to cancel out the milliliters that are on the bottom. So we're going to multiply by 250 milliliters. So those cancel out and we're just left with grams. So now we can just plug this into our calculator and you get approximately 13 grams of dextrose. And we want to round from I think you get 12.5 out of your calculator. And since we start with 2 sig figs with this 5.0 grams, we're going to round to 13 to have just 2 sig figs in our answer. So question 2 is asking to determine the number of moles delivered in the above scenario. And so we know that we start with 13 grams, and to go from grams to moles, we know that we have to divide by the molecular mass, but we don't have that yet, so we want to figure it out. So we're going to leave the start of the problem on the left, and then we're going to just calculate the molar mass really quick on the right. So to start with, we're going to take our formula here, and we're going to start with our 6 carbons, and the molar mass of a single carbon is 12.011 grams per mole. And then we're going to add the 12 hydrogens, which each have a mass of 1.008 grams per mole. And then finally, we're going to add those 6 oxygens, which each have a mass of 15.999 grams per mole. So if you plug all of this into your calculator, you get approximately 180.156 grams per mole. So that is our molar mass. So we're going to go back to our mass over here on the left where we have 13 grams. We're going to divide by that molar mass that we just calculated. And because we divided, we can cancel out these grams, and this is on the bottom of the fraction in the bottom of another fraction, so that brings it up to the top, and we're left with 0.069 moles as our answer for number 2. And then